My name is Luke Teverino and this is my Lab 3. Goals and purpose. Lab 3's purpose is to reinforce the relationship between the equation F net is equal to change in momentum over change in time, also known as Newton's second law, through the calculation of a black hole's mass. As we work to calculate the mass of the black hole with limited variables, we are forced to use the relationship between F net is equal to change in momentum over change in t, rather than calculating through other kinematic methods, and thus reinforcing the relationship between force and change in momentum. A final key component to this lab is understanding how we can split delta P into parallel and perpendicular components. This is done through the use of direction of net, delta P, and the direction of the velocity in that point of time. Using velocity as a reference, we can break the net delta P delta T into its components, which also directly relate to F net's components. Let's go through some of my code. So my seed was my email. The star's mass is what it told us it was supposed to be. Delta T is time of 1 day in seconds. And then for my arrows, I made them accordingly. For my code continued, V initial is equal to V initial times mass because momentum is equal to velocity times mass. And then same for P final. And then the change in velocity is V final subtracted by V initial, same with delta P. Delta P dt is just the change in momentum over the change in time. F net is equal to delta P delta T due to Newton's second law. P hat is equal to norm V initial, and the rest goes through there. And then you can see delta P parallel is equal to D mag dP times P hat. And as we can see here, F net parallel is equal to the change in momentum parallel due to Newton's second law. Just for the same reason, F net is equal to the change in dP dt net. And then continuing on, F net perpendicular is also equal to dP dt perpendicular. And then as far as my mass, I just rearranged the gravitational force equation to work out so that we can find one of the masses, which is the mass of the black hole, and that's mvh. And this is what it looked like after it ran. Sorry for the not so good quality. Now to find the average black hole mass, because we really have to find it at each point of time, we can't really find an overall mass. So what you have to do is you have to take all of the points of time mass and then you have to average them. And my average mass is 1.91 e to the 34th. Yeah. And then for the questions, what does it mean? In your analysis, you should discuss how the net force and its parallel and perpendicular components are different from the rate of change in momentum in its parallel and perpendicular components. Well, they're not different at all. F net is parallel is equal to change in momentum parallel, and F net perpendicular is the change in momentum perpendicular, as we can see in my code, and this is due to Newton's second law. What if? Imagine the black hole whose mass you found was removed, and a different black hole was placed in its same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? Well, in short answer, it's no. It would be impossible. Due to the motion of the observed star remaining the same, the forces are the same, and also the star's mass is the same. Thus, the black hole's mass must be the same, and we wouldn't be able to tell a difference. Thanks for watching. This was short and sweet. I appreciate it. Luke Teverino.